You've probably all heard the term deep energy retrofits. You may be less clear on what that term means and how it might be relevant to your organization. We have 3 panelists with us today to help you answer some of these questions. We'll hear from Cara Carmichael at the Rocky Mountain Institute, who'll provide us with a primer on deep energy retrofits from RMI's perspective. Next, we'll hear from the commercial building owners and managers detailing their firsthand experiences with these kinds of retrofit projects. Carlos Santamaria from Glenborough will highlight a retrofit of the Aventine building in La Jolla, California. And Jim McClendon from Walmart will discuss Walmart's process at the portfolio level for achieving these kinds of large energy reductions. Next slide, please. So here's our, I think we missed our agenda, but I'll just go through that real quickly, which is we'll hear from all 3 of our speakers, and then we'll we'll look at a couple of resources that each of our presenters have provided for your use, and then we'll move right into a question and answer session where we'll ask all of your questions that we've collected through the 3 presenters this afternoon. So let me go ahead and introduce our first presenter, who's Cara Carmichael. She's a senior consultant at the Rocky Mountain Institute. She's been working on deep retrofits since before the concept of deep retrofits was cool. Her background in both architecture and engineering has served as the cross-disciplinary foundation for her passion for working on troubled buildings and portfolios. Cara led the creation and content development of the Retrofit Depot, the foremost online resource about deep energy retrofits. You'll see more about that later in the presentation. And she continues to lead the effort at RMI focused on implementing the deep retrofit business model within energy service performance contracts, ESCOs. She has also worked with GSA on their National Deep Energy Retrofit Program, Better Plants partner Ford on their Green Dealership Program. Carlos Santamaria is Vice President of Energy Services at Glenborough, LLC. He also wears many hats in the professional associations that he works with and promoting energy efficiency more broadly. He is the Vice Chair of the Building Owners and Managers Association, BOMA International, the Energy and Environment Committee, a Board of Director and Chair of the BOMA California Energy Committee, and a steering committee co-chair with the Department of Energy's Better Buildings Alliance Group. And last but not least is Jim McClendon, who is a mechanical engineer and director of systems engineering for design and construction at Walmart Stores Incorporated. Mr. McClendon joined Walmart to develop new prototype store designs and retrofit strategies to reduce total energy consumption in the new construction and the existing store base. In the spring of 2013, Walmart stated a new energy goal to install 7 billion kilowatts of renewable energy and reduce the global building footprint energy intensity in kilowatt hours per square foot by 20% by 2020. Mr. McClendon leads the team in response to the energy reduction component of this goal. So thanks very much to our presenters, and without further ado, I'm going to turn it over to Cara, who will talk about the who, what, when, where, and why of deep energy retrofits. Cara?
Great. Thanks, Holly. And thanks to everybody for joining us today. I know that time is tight during the holidays, and so we're excited to have such good turnout. Next slide, please. First off, what really is a deep energy retrofit? Usually we target 50% energy savings or more, but perhaps more important than the specific number is the process that is used to get there. On all our projects, we use an integrative design and analysis process, and this doesn't necessarily need to be a cumbersome sidebar that increases time and cost, but rather just a carefully engineered strategy. The design process for new buildings, I think, has gotten much better in the last 10 years. Yet retrofits are often thrown together under such tight deadlines with far too little information to make good decisions. So the deep retrofit process really drives towards improved project economics, bigger savings with equal or lower capital costs using whole systems design. It also uses a life cycle metric to drive decisions, not necessarily simple payback periods, but net present value, for instance. The deep retrofit process also factors in the value beyond energy cost savings. So it is widely accepted that this value beyond energy cost savings is not zero. However, calculating that value and using it to make decisions is not necessarily commonplace yet. I'm talking about the benefits to occupant productivity, recruiting and retention, and brand enhancement that a deep retrofit can really provide. And ultimately, the more deep energy retrofits we have will drive long-term improvement in the building stock to enable a modern, dynamic, distributed, renewables-based electricity system. Next slide, please. A deep retrofit requires a shift in the approach to a retrofit. And I can tell you that just adding more stuff, piling on more measures into a retrofit project really won't get you there. It needs to be a part of the strategy from the start. Next slide, please. So I'd like to briefly walk you through, in my opinion, what are the top 5 things that make a deep retrofit project successful. Pursuing the right steps in the right order, looking at deep triggers, using focused analysis such as the technical potential exercise and bundling measures, defining business as usual expenditures, and quantifying the value beyond energy cost savings. Next slide. So when you're approaching a deep retrofit project, it's important to figure out what really needs fixing and understand the underlying motivations for the intervention. So we found that most people go directly to the equipment and the widgets for answers. They start at step 5. If people are hot, we need a bigger chiller. When really, if you can do a little bit more digging, perhaps it's just a vocal occupant in one space who were uncomfortable because the ductwork we came to find wasn't actually connected to the space, but just blowing conditioned air into the plenum. This happened on an actual project. But it turns out we were able to plan out the replacement for a smaller chiller while fixing the ductwork and incorporating a few other measures to actually reduce the overall energy use in the space. But in this list of steps, step 4, reducing loads, is perhaps the most important step. And even if a building isn't ready for a deep retrofit tomorrow, this is a step that needs to happen if you're considering a deep energy retrofit leading up to that more comprehensive intervention. Next slide. So since not every building is ready for a deep energy retrofit right now, these are some of our items to help figure out which buildings are ready for a deep retrofit. So the whole idea here really is to piggyback off the money that you have to spend anyways, or the hassle that you're already going to have to go through for the occupant. So if you're considering a planned capital improvement, if you're undergoing a major system replacement, and by systems, don't think just mechanical systems, but also envelope systems or plug load or computer equipment, other components, other systems. If you're looking at code upgrades, new owner refinancing, if there's a change in occupancy type or tenant, green building certifications, there's significant utility incentives, or if you're just mitigating an energy hog of a building. Next slide. So the technical potential is defined as the maximum level of savings possible given today's technology. So what this means is if you were to totally overhaul a retrofit, setting aside all constraints and do everything technically possible, how low could you really go? What is that level of savings? Then tune back into reality and layer in some of the constraints that we all have, such as time, costs, tenant or occupant considerations. And then where do you end up? That is the implementable maximum amount of savings that you can achieve. And so this approach is really important because it takes the typically additive approach to retrofits, and that we start from the problem, something's broken, we got to fix it, and keep adding different things to the mix. And rather, it makes it a subtractive approach, making the team justify any subtractions in savings. So it changes the design paradigm from, oh, we can't do this because, ... to really, well, we could do this if. if we had this in place or that in place. And it challenges conventional thinking and leads to much more aggressive design targets. Next slide. So another really important component is bundling measures. And a bundle is a combination of individual energy efficiency measures that are analyzed together. And the purpose of bundling is to evaluate the synergistic benefits of measures. For instance, how a window replacement has a significant impact on the HVAC and control system. And this practice is really critical to realize cash neutral or cash positive deep energy retrofit. Bundling measures also often leads to downsizing mechanical systems because specific collections of measures can greatly reduce heating and cooling loads. For instance, we worked on a high-rise project in Germany that was able to take back a whole floor that was previously devoted to mechanical systems and turn it back into leasable square footage. The load reductions in the space due to plug load measures, envelope measures, and others enabled systems to be downsized and eliminated, thus returning square footage into usable area. And fortunately, bundling is a relatively straightforward analysis process. Next slide. So estimating the cost of business as usual may sound pretty simple and obvious, but we've found that decision makers often don't consider this as part of a retrofit. And this is really important since it puts a real life cycle cost to doing nothing. A deep retrofit provides significant cost savings when compared to the life cycle cost of a business as usual scenario. And this business as usual scenario should include utility bills, maintenance and operation costs, cost of replacements, incremental upgrades, any required code upgrades, carbon taxes, and any costs due to service interruption or disruption. Next slide. And lastly, a successful deep energy retrofit needs to factor in the value beyond energy cost saving. Any CEO worth his or her salt will weigh the trade-offs of any expenditure that they make. And as it turns out, energy cost savings is really, it's a pretty small dollar motivator. And this data comes from a BOMA study that reports the average business spends the vast majority of its operating expenditures on salaries, on people, 90% if you include the absenteeism and presenteeism related expenses. So energy really is a pretty small sliver at less than 1%. Next slide. So RMI has spent the last 2 years putting together a framework to make these values more tangible and more concrete. And actually on January 15th, we'll be releasing this framework, and it'll be able to be found for free on our Retrofit Depot website, which is listed in the resources section. But what we've done is we've defined 9 key categories of value that a deep retrofit provides. And these are just a few examples of those categories. And so if we look at the middle one, improved reputation and leadership, that value is created by recruiting best employees or tenants, increasing tenant satisfaction or retention, public relations and brand management, and this framework will help a company understand those and put numbers to them. Next slide, please. So what is coming out of, what are we seeing in other real-life examples of deep energy retrofits? What lessons can we learn? So the New Buildings Institute recently published a study that looked at 50 deep retrofit projects across the U.S. of different types and sizes. And here are a couple of takeaways from the study. I just want to highlight the first one, which really focuses on integrative design, and bundles of measures are more critical than any one technology. So these projects were not made from one technology. It took multiple technologies, often integrated together. And in large part, that technology was off the shelf. So we're not talking new widgets that have yet to be developed in order to get to cost-effective deep retrofit. The technology is there. Next slide. So we've done really big, impressive single building energy retrofits, like the Empire State Building and some of the others that Jim and Carlos will talk to. But a single remarkable example, it's not really going to get us where we need to go. Next slide. So we need to achieve deep energy retrofits in many, many buildings and start looking strategically at entire portfolios of buildings. And that's a lot of what both RMI and BBA are working on. Next slide. So RMI's portfolio strategy at a very high level consists of three main steps. First, doing a strategic energy analysis at the portfolio level. And this relies on good granular data, which can be really challenging, but is paramount. Then the portfolio is segmented into a few key groups, and next the buildings are bundled, not only based on physical characteristics and climate and as such, but there are several other key factors that we use to lump those buildings, in part policies, energy measures, and financing. Lastly, map parallel paths for each group of buildings. And this includes creating a life cycle energy master plan for each building or group of buildings. So there are a lot of different levels that should be addressed, from vaccination, simple troubleshooting or recommissioning level activities, to reviewing some of the deep triggers that I mentioned earlier to see if a building is actually right for a deep energy retrofit. Next slide. Thank you.
All right, thank you, Cara. As I mentioned, we'll be doing questions at the very end of all three presenters. I do want to point out on the portion of your webinar screen where you have a chat function, you can send questions right into us. We'll be collecting those throughout all of the sessions and queuing them up for the end. So let's move right along to Carlos Santamaria at Glenborough, who's going to talk with us a bit about his real-world experience of deep energy retrofits in La Jolla. Carlos.
Hello, everyone. Thank you for this opportunity today to present on some of the, or one of the really important successful projects that we implemented at one of our properties in La Jolla, California. Next slide, please. So we'll talk about the Aventine office building, which started our analysis back in 2006 and 2007. And over a course of several years, we really accomplished a lot. So I'm excited about going through some of the steps, you know, in a macro sense and a micro level, so you get a better understanding of what we were able to do with this older multi-tenant building. Next slide, please. A little bit about our company history. We're a nationally recognized company that takes care of commercial real estate all over the U.S. Next slide, please. So this case study, you know, it didn't happen over a year or two. It took several years. With deep energy retrofits, they usually take a number of years, or they could, if you throw a whole lot of money at them, take place over a quick period of time. It just depends on your strategy, ownership willingness to make the changes at a time when, you know, cash could be an issue, or at a time when, you know, you have a full building or an empty building. So, you know, the project, as I said, started prior to 2008 when we actually started doing the work. We started analyzing our portfolio, identifying candidates that were those that would best fit a deep energy retrofit, and the Aventine office certainly was one of the candidates. Next slide, please. And, you know, this case study is really an example of how a dedicated effort by many individuals can really result in an above-average outcome. The project started with the vision, of course, and we really reached the highest level of energy efficiency and sustainability at this one particular property. Cara had mentioned about in a sense or two, a whole building integration approach. And I can't stress that enough, that it's really important to look at, a number of different of the energy resources and operations throughout the building, and you'd be surprised how you can uncover a number of opportunities and savings. Next slide, please. So this building itself, again, located in La Jolla, California, is a Class A multi-tenant building. And when we started the project, it was a relatively new building by today's existing building stock age. It was 18 years old, and getting decision makers to spend a lot of money and replace equipment was challenging, but we went through the particular steps in order to get buy-in, showed the benefits, and as it was mentioned prior, we bundled a lot of different measures to get the synergies, the attention, and the buy-in to start this project. So when we started the project, right now it's 23 years old. It's approximately 252,000 square feet. Back in 2007, prior to implementing this project, it had an ENERGY STAR rating of 84, which is pretty good by today's standards, meaning it's in the top 16% of all buildings out there that are in ENERGY STAR in the Portfolio Manager rating system. The cost per square foot to run the building all in was roughly, or the electrical cost, roughly $2.90, $3 a square foot at those rates. Next slide, please. Now, we're going to start with the overall general results and back into how we obtain, next slide, please, how we obtain these results through this deep energy retrofit strategy. So what did the building accomplish? Through this effort, it entered a LEED certification program in which it scored 71 points and was qualified for LEED Platinum back in 2010. When we started the project in 2008, some of the deep conversions, as I'll mention here later on, we immediately after the first year jumped to 100 on the ENERGY STAR score. It was amazing some of the major changes that were made, how it really increased the ENERGY STAR rating. And over the last 5 years, it's maintained a ENERGY STAR score of 100 and has a kBTU per square foot all-in rating for the building of 23. Next slide, please. So in looking at some of the accomplishments, the whole project over the course of 4 or 5 years reduced approximately 1.2 million kWh of energy, which also reduced over 700 metric tons of CO2 carbon emissions. And this is really important, that to remember that deep energy retrofit should look at all of the building's energy sources and waste in a building, and which we did as we started to look at the different systems, opportunities, and the way that we were running this building. It really did uncover a lot of opportunities, which we'll go over here. And I can't stress enough that having a strategic vendors energy team was critical to us. Not all of us have all the answers to the specialized systems and protocols, new technologies and ways of making some of these energy efficient upgrades. So you bring in the best and you get the best results. Next slide, please. This was our strategic vendor team, and as we started to do some of the deep energy retrofits and system changes, we also at some point started a LEED certification project, as I mentioned earlier. So we enlisted many and got onto our team many vendor experts out there to help us in this endeavor to reduce a significant amount of energy and turn this into one of the most energy efficient buildings in the nation, if not the world. Next slide, please. And this is just, again, showing how our project team members incorporate everyone from building engineers to property managers to third-party engineering company representatives to LEED certification project managers and to our own senior leadership team. Next slide, please. So this is really what started. This is a three-phase approach that we looked at, which steps 1 or 2 are the most important parts of this approach, and energy profiling and prioritizing the data. Next slide, please. And back in 2007, 2008, we did not have the luxury of having a sophisticated energy dashboard to really look at and evaluate how our energy use breakdown was laid out. So we did this all with calculations, building a tool ourselves to identify which of these was the biggest area to go into and spend our money. As you can see from this slide, it was the HVAC system in the building. Next slide, please. And as we narrowed down to where that large percentage of the energy was being utilized, it was in the chiller plant. So what did we do? We looked at the controls, a major retrofit, and how it was operating and how it was controlled, and we increased our efficiency, improved it from 1.4 kW per ton, and that was wired water, to 0.4 to 0.6, and that's a 57 to 71% efficiency improvement just in this one area of chiller control and energy usage. Next slide, please. By using these technologies, I can't stress enough that these new technologies and programs provide a high energy savings consistently. And, it's easy to put in a system and have operators and individuals change how these systems are controlled and operated. So that's why you need to use automated programs to really assure some of the energy over time. Next slide, please. Again, talking a little about the improvements from an 84 to 100, but I think in California, when you look at AB 32, the Global Warming Solutions Act of 2006, especially in California, this one metric alone should motivate more individuals and organizations toward performing these deep energy retrofit strategies, because when you look at the results, they're pretty amazing. When you see prior to the project you were spending roughly around $3 a square foot, and now it's way under, even though this shows back in 2007, 2008, $2.20 per square foot. Today it's at $1.95 a square foot. Next slide. We'll go over this quickly. This was just some of the tools that were used. We replaced the old inefficient R11 compressors with these new technologies of turbo core compressors that are an all-drive, very smart chiller. Next slide, please. Real-time energy metering with deep energy retrofits is critical. I can't stress this enough. And as you start to implement and layer in some of these projects and solutions, to have the granularity of being able to look at your meter information is critical. Next slide, please. We implemented a few years back Internet's Insight Energy Dashboard that really gives us a good granularity and insight into how our building's energy is performing, and really looking at the energy curves to see how we're modeling and operating our systems. Next slide, please. You can advance this one. As I just spoke about, having meter granularity is really important. Again, whole building integration, looking at other systems and practices is vital. And again, looking at the waste and water is important. And the education, I can't stress enough reaching out to those within your organization and the industry to bring these synergies and best practices to your organization. Next slide, please. That's a little bit about what this slide here, about what was accomplished in replacing the old rock gravel roof to a cool roof, saved almost 50,000 kWh of energy. Next slide, please. We looked at water conservation as also a strategy. Next slide, please. And then, again, we looked at outside landscaping areas to where we can reduce water also. Next slide, please. And as we finish up, we also looked at waste management practices. Again, we looked at the whole building integration, everything coming in, everything going out, and how this could we could improve the sustainability and energy of efficiency of the project. Next slide. And in closing, this was the result. We were one of 20 LEED Platinum multi-tenant buildings in the world, and probably one of the few that has an ENERGY STAR rating for the last 5 years. So this is a poster child for energy efficiency and really a good model for sustained energy performance. And if anyone has any questions after the webinar, please feel free to send me an email or give me a call. Thank you so much.
Great. Thanks very much, Carlos.
You're welcome.
We already have a number of questions coming in to us on the chat window, so please keep them coming. We're taking them and lining them up for our panelists at the end of the session. Our next presenter is Jim McClendon, who will take a portfolio-level perspective and discuss Walmart's process for identifying and implementing energy-efficient technologies in many buildings at a time. Jim.
Thank you very much. Welcome, everybody. Appreciate you taking time out of your day to attend. Next slide, please. So we're going to shift from a building perspective to a portfolio level, which is more of a projects-driven approach when you're looking at large-scale portfolio management. Going building by building has a whole different set of challenges. So we typically look at projects and bundling, to Cara's point, projects, but then those are driven through the enterprise, primarily driven from resources and logistics, which are key, as opposed to individual performance enhancements on a building-by-building basis. It's just not practical to do an entire building, then move to the next building, and move to the next building. What's typical is you're running, let's say, 1,000, 1,500, 2,000, fan retrofit projects at once, as opposed to building by building. Next slide, please. So just to give you an idea of what we're talking about on large portfolio, for us that's about over $1 billion. Globally it's about 1.2 billion square feet, 1 million customers a week, a couple of million associates, over 10,000 stores in 16 countries. So a reasonably sized portfolio to manage from a project-by-project basis. Reeling that into U.S.-centric, which is our focus today, that's about 850 million square feet that we'll be talking about. Next slide. So to outline portfolio approach, it helps to have an objective. And so a quick history lesson to perhaps draw an example of project-based portfolio approach towards energy efficiency. 2005, we stated an objective for a 20% reduction over the next 7 years. Next slide. And so in doing that, you need a roadmap. So this is just a snapshot of what that roadmap both evolved into, what it started out looking like, some changes that occurred during that. And then when you're done, your strategy and your work plan becomes a KPI along the way that you can measure both internal and external performance factors. There's a lot of variables at play, and some of the key accomplishments along the way are highlighted in yellow there, which were some DOE partnership projects that both helped our program launch and then also helped the industry launch around the areas of LED lighting, for example. Next slide. And so that gives you an idea when you're talking about project-based portfolio management, what kind of projects are they and how do they cluster up? And so you can see over from 2005 to 2011, there were about 8,000 projects implemented, this is U.S. only, in these different areas of technology. And, some of the examples you can see, 2,000 projects regarding LED freezer case lights that amounted to about 100,000 metric tons of greenhouse gas reduction, air handling reduction projects, so forth and so on. So you can see it becomes quite a matrix of projects to manage on a portfolio basis. Next slide. So what that results in is that some stores end up getting a lot of projects and some stores don't get any projects. Again, we're managing portfolio-wide on a project basis. Sooner or later, you will saturate the inventory with all of those projects. With the interim, what happens is, as you see here in this small sampling of some stores, some stores did very well based from 2006 to 2012, pushing 30% reductions. Other stores that perhaps didn't get any retrofits or had additional headwinds of additional category changes, refrigeration loads, and so forth, actually went the opposite direction. Next slide. Therefore, we need to manage at an aggregate level. So we look at project management on a portfolio basis, and we measure in the aggregate. So if you look at the entire U.S. fleet over that period of time, roughly 5 years, you can see that while growth was sustained, the actual EUI decreased about 15%. Next slide. So that's just kind of what happened to give you an idea of the project management. And so the question is, big deal, that's history, so what's next? And what we're looking at that was mentioned at the beginning of the session is the next goal, which is an additional 20% in kW per square foot, kWh per square foot reduction by the year 2020. Next slide. So we'll be starting off where we left the previous goal. So this is, again, just a small sampling of some buildings and stores, and you can see on the lower left-hand corner that from 2006 to 2012, most of these have a slope downward, meaning that they're representative of that aggregate 15%. Some of them go the opposite way, but as in general, we're starting with a reasonably efficient improvement on a fleet. Next slide, please. So the focus in doing that is on the existing footprint. We can build exceptional projects from now till 2020, or we could build minimally compliant projects from now until 2020. And the truth is, it's not going to matter on the goal because the footprint is so large, it has to be achieved in the existing footprint. And this graph illustrates what's pretty typical for, I think, a national average, in that the year 2020, 87% of the buildings we own today will own in 2020. So it just illustrates you have to look at the existing footprint. Next slide. To make it harder, it's a relatively young fleet of stores. So most of those are 10 years or younger, or 15 years and younger, meaning that the opportunity for major asset replacements are limited because some are still operating, some are still running in depreciation schedules. Next slide. And as an example of that, refrigeration racks, there's 14,000, 15,000 of them that are still 5 years away from end-of-life value. Next slide. About 85,000 or more rooftop units that are under, end-of-life replacement and still in that depreciation schedule period. So again, it comes back to energy efficiency projects that can be implemented very large scale, portfolio-wide. Next slide. And so an example of how that manifests itself into project management is on the left-hand side of this graph. You can see the 8,000 projects I referenced before that were accomplished over a 7-year period. And that was the approximate distribution of those projects. Going forward, to achieve the same goal, it's going to be a factor 3 of those projects. And again, most of these are not necessarily full asset replacement projects. They're energy efficiency technologies, optimization strategies, and so forth. Next slide. And next slide. So the approach we're taking, which is similar to what we've done in the past, we look at our typical store and basically break it into 3 different building types. On the top is a grocery store, in effect. In the middle is a general merchandising box, and then on the right-hand side is what we call a seasonal box. And those have different opportunities for energy efficiency, and they have different demands on the building type to support the business. Next slide. So a very fundamental strategy forward, the first and foremost is understand the footprint, and both Carlos and Cara made that point. I can't emphasize that enough. It's extremely important. You have to understand where you're at to know where you're going. Then once you understand that footprint, you look for patterns and trends. You establish your norms and identify the outliers, and then you work towards an ideation process around those projects. And for us, that's looking at and assembling subject matter experts that can pull these ideation together. We sort it by load reduction, free energy, and efficiency in that order, which is pretty fundamental, elementary approach. So we're not doing anything super scientific here. And then we filtered by what we call OTS, ROTS, and NT, which is off-the-shelf technology, reworked off-the-shelf technology, or new technology. And given our scale and the opportunity at hand, if it's an off-the-shelf that with minor modifications, say a controller that needs more headroom or what have you, oftentimes we can partner up with manufacturers and we can drive a rework of that technology to hit the application and then also make that available to industry as well. Next slide. So understanding the footprint can be as high level as just simply aggregating utility data. Here's the sampling of some stores. It's just very high level electric and gas data. But when you do that and you pull it out, you can start to pull together regional variances, common denominators. You can look at similar formats. Then you can separate into quartiles and start to do some analytics to just understand that footprint. Next slide. If you happen to have sub-meter data, you can do the same thing where you have the opportunity to separate into HVAC, lighting, refrigeration, and so forth. Again, drawing similarities, anomalies, common denominators, and so forth of that data, and it really paints the picture of the opportunity. Next slide. It's just a quick snapshot. You've seen this stuff before, but again, you can trace through here. The green in this case is a lighting signature, and you're just looking, does it meet expectation? Does it pass the test of reasonability? And then you start to, again, look for those outliers. And so this is a 15-minute view on 24 hours, so it's a diurnal look at the data. Next slide. Same thing, you can look at seasonal variations. So again, if you've got this kind of information, great, compile it with the utility data. Next slide. At some point, when you have a large portfolio, you're going to have to do deep dives. And here, you got to get really into the weeds and understand the energy flow and the energy maps for each segment in each part of the building, which is what's illustrated here. Next slide. And then to take that to the next level, you look at, in this case, just the refrigeration component. And again, you have to do the deep dive. And in this case, this is physically going out and installing sub-meters in a statistically sampled set of stores that can represent an aggregate base. You have to look at all of these little elements to understand when an opportunity is presented and somebody gives you the classic 20%, I'll save you 20%. Well, you have to be able to identify and defend 20% of what, and what does that mean in return on investment, and am I going to meet my hurdle, and so forth, and you have to be able to defend that to audit. Next slide. And so, kind of as an overview, for us anyway, it's define an objective. It's always easier if you have an objective, some kind of goal at the end of the tunnel. And then it's project-based. It's fill the funnel with projects and then implement across a portfolio, primarily driven by resources and logistics. The basic concept is assembling a diverse group of subject matter experts, explain the objectives, outline the limits and boundaries, and by that I mean we're very focused on the existing footprint. So boundaries in an existing operating store, for example, means we're not going to tear out the concrete floor and put in a radiant floor in an operating store. So let's just put that outside the boundaries right now, and let's save that for a white paper exercise on new design. And then give them the tools, and the tools are what we just looked at, understanding the footprint, the identification, and the energy maps so you can get into the weeds and understand energy savings in a certain category means X in dollars. And then know your subject matter experts. They're available to everyone. You have them internally to your organizations. You have consultants and so forth, external. Your utilities provide subject matter experts. Department of Energy, universities are looking for partnerships. So there's lots of subject matter experts out there, at least it's been our experience. But a key from our perspective is to assemble them in a blend. So you've got some blue sky thinkers coupled to boots on the ground people. So the end result is something tangible that you can use and not a theoretical target that's hard to achieve in practical measures and economic terms. Next slide. And so this is just one method we use when we're looking at ideation coming from this panel, say of subject matter experts. We first sort them into the load reduction, free energy, and energy efficiency improvements in those orders, always load reduction first. And then depending on what the idea or the concept is, does it fit in an OTS, ROTS, or NT, or off-the-shelf reworked off the shelf or new technology category. And then simply follow through a flow chart which asks some key questions to your organization on tests of reasonability and find, the end objective of putting it in the appropriate funnel, which is basically high priority or low priority. Everyone has limited resources, and so you want to apply those resources to the highest return possible for projects. Next slide. Thank you very much.
Great, thanks so much, Jim. So we've had our 3 presentations. We have a boatload of questions, and we have a good amount of time, at least 10 minutes or so, to go through some of those questions with our panelists. I want to quickly note a few resources that our panelists have provided for us for this presentation before we move into that Q&A portion. Please also note that an archive of this entire presentation will be posted to the Better Buildings webinar series website, and you will all receive an email as soon as that archive goes up, and there will be links to all of these resources there, as well as contact information for all of our panelists if you have additional questions you want to touch base with them on. So first we have the Retrofit Depot, a link to that website that Cara mentioned during her presentation, which is really just a fantastic, very comprehensive resource on these deep retrofits and how to do them and how to think about doing them, as well as a link to the Rocky Mountain Institute in general. 3 case studies from Carlos detailing the work that happened at the Aventine, and one of those detailing specifically the work that they did at the chiller plant. Finally, Jim provided a link to Walmart's energy page, actually energy website within the Walmart website, where you can find a lot of detail on the specific energy reduction strategies that Walmart is working on across their portfolio right now. Excuse me. So let's go ahead and move into the Q&A portion of our session today. And I'm going to start out with a couple of questions going back to Cara. So one of the questions, Cara, from our audience was asking about data and the kinds of data loggers that you find to be most useful in getting the data, getting building data to sort of start your analysis, and what building data is the most useful to capture?
Mm-hmm. This is a great question and gets at really some of the starting challenges that a lot of projects have. It's not uncommon. We're not necessarily proponents of any single technology. I think there are a lot of great controls out there and great data feedback systems. I think the most important thing is to get the granularity of data, excuse me, that's needed. So at a high level, you really do need building by building data. So not kind of a bunch of buildings lumped on a single meter. If you can have that, that's a great start. And then, as Jim mentioned, getting down into the end-use data is also very helpful, although something that you can back your way into if needed. But it is helpful to know, how much lighting or heating or cooling is contributing to the building.
And Cara, do you have a perspective on which sector you think might show the most promise for deep retrofits in terms of corporate office space, healthcare, schools, et cetera?
I don't mean to sound vague here. I think that they really all do hold promise, and I think it comes down to the triggers and whether a building is ripe or not. I mean, I think schools are a great opportunity because usually there's a long-term holding period. Healthcare is really great because it has a really high EUI. It's a very energy-intensive building type, so improvements, holistic improvements, can save a lot of energy. And corporate projects, they have the financial motivations that really, if you can put together the right bundle of measures, can really have a favorable return. I think you need 2 or more really of those triggers that I mentioned to really hunker down and look closely at a deep energy retrofit.
Great. Carlos, a couple questions for you about the Aventine. So we had a question here that says, if the Aventine was pretty good with Energy Star score of 84 to begin with, and a fairly new building, why do the retrofit? How did you choose the Aventine when it was already performing so well, or relatively well?
Right. That's a great question, and I think a lot of buildings and owners face this question and challenge. Well, we had energy savings opportunities at the building. We wanted to be proactive versus reactive in how we addressed energy usage, and really wanted to turn our buildings, our portfolio that Glenborough was managing, into the most energy efficient and comfortable buildings, in the market that they're in, allowing our investors high returns and our tenants to have low operating costs and good HVAC, indoor air quality environment, so that their employees could be productive as possible. So that was probably the driver. And as we started to get into this too, I think it was more of a drive for excellence for our company to show how we were able to transform average to underperforming buildings into high-performing, energy-efficient and sustainable buildings.
So a couple of questions, Carlos, around money and
Sure.
payback.
Money.
So money, who cares about that? We did have a couple of questions on that. One was just what was the total cost of the project, and then folks also asking about internal rate of return, simple cash payback time period, ROI, any of those metrics that you have available to share?
Sure. The payback was under 3 years, a little complicated only in that we had some tenant participation with one of the major tenants that had a 24-hour fitness center that was causing the chillers to run, probably 20 hours a day, so we were able to really reduce that. It was over a 35% ROI. We had a lot of deferred maintenance opportunities, and in our capital replacement project overall 5-year plan, we were able to extend and or reduce what that capital replacement plan looked like. And then the tenant retention was huge. It cost a little under $700,000. Now I know there are a lot of people trying to pencil in a lot of things, but it's hard to really sometimes quantify the savings, the payback, because it's always a moving target. The rate of electricity, what you buy it for, when tenants move in, when they move out, how you can recover some of those costs, how you can recoup some of the tenant extra air. So it was, again, ROI above 35% and overall energy reduction over 30%. And one of the major increases or benefits, we saw above $3.5 million in asset value, which provided the building, as far as incentive, to be really a high-profile buildings, and some really high-profile tenants moved into that building also.
Well, and you mentioned the tenant retention, and that touches on another question posed by the audience, which is, can you describe the value beyond energy cost savings that Glenborough realized from this project?
Oh, I think so. I mean, one major factor was in that market, we had a major tenant move in as their area regional headquarters, CoStar, and they knew it was a Energy Star rated building at 100, platinum building, and they came in and built out their space to platinum CI. So I think that's an indicator that those things matter to the right tenants in the right market at the right economic time.
Great. Thanks so much, Carlos. Jim, I have a couple of questions for you as well about some of the specifics. I know a fair bit of the retrofit work that Walmart is doing is around lighting, and one of our questions is related to your exterior lighting. What has been your experience with LED exterior lighting? And the person who writes in says, we saw many failures in our projects, and wondering if you have also.
We've had really good luck with the exterior LED lighting program. To be to be honest, it actually launched for us in the international markets. We had better opportunities there with scale and application and rate basis, so we were able to drive to a better return on investment for us by leveraging through our international markets first, and then we brought it into the U.S. as prototype for new stores and as an active retrofit program now. And so for us, we've had good luck with the application, with the product, and I believe the manufacturers are confident with it now that it comes with a 10-year manufacturer's warranty.
Great. Another question asking about whether or not you all have considered a continuous commissioning process, more focused on operations and maintenance and overall optimizing energy management as opposed to a more technology-focused retrofit program.
Yeah,
or if you're as well.
Yeah, absolutely great question, and that hits the nail on the head. You can spend time and money putting all of these projects and retrofit measures in place, but if you don't have a program to sustain them, it's all for naught in time, and you won't recap your investment based on your projected returns. So we are working that in parallel. We're looking at a globally based energy informatics development process now, which would be, at the store level, manifest in a dashboard approach where each store can look at its performance compared to the store's performance of similar formats in the same market, and provide a measurement basis for KPIs, and then also provide a visual tool for behavioral changes at the store level. Absolutely agree.
Great. I have a question which I think I will. Well, I'll open it up. I'll let you all fight over it. Heating and cooling and lighting are well known as the big three in commercial buildings, but as we improve those, pesky plug loads are a growing piece of the whole building energy pie. Any experience tackling those and their contributions to deep retrofits when HVAC and lighting aren't lousy?
I could talk a little bit about that, only in that we've done some pilot programs at some of our buildings, not only with PG&E but with the DOE, in looking at plug load. And I think the challenge there is having the granularity and a cost-effective metering strategy. And the industry is changing drastically right now to where we have wireless technologies, and the cost of putting in the meters and actually extracting the information and making sense out of it is getting a lot better. Tenant engagement programs are being utilized that do make a difference. So I think in the plug load area, you could see anywhere from 7 to 15 to 20% reduction in a lot of cases, and it could be a substantial reduction. But we're not quite there yet to be able to control, look at, and manage plug load in a cost-effective manner until that a more cost-effective metering strategy and alternative is available.
I think you're exactly.
Go ahead.
Sorry. You're exactly right, Carlos. And the only two things that I would add are there's a lot that can be done just within the IT programming aspect, when computers go into sleep mode, when they're charging, how often their screensaver comes on. And then the other thing is a corporation's purchasing policies, how often and what kind of technology is preferred purchasing. It's also a big driver.
Yeah, this is Jim. I would just agree and concur with that, in that miscellaneous electric loads, or MELs, has become a target category for us, as well as along with HVAC, lighting, refrigeration. In 2005, MELs was probably in the 11-12% of the total profile, with efficiency improvements in those other areas and nothing really addressing MELs. It's creeped up over 20%, 25% in some of our stores. And so we're doing a lot of the similar things. We're doing deep dives to measure exactly what those loads are, what the intensities of those loads are, and identifying what some potential control strategies and applications may be. For us, it's a very complicated area because there's hundreds and hundreds of these loads in a store, and often they have different owners from merchants driving the group or driving that particular area to supply chain that provides some of those displays and so forth. So it's complicated, but it's becoming a large enough chunk that it warrants a lot of attention.
Okay, folks. Well, we have a number of other questions that we weren't able to answer today. We're right at our 4 o'clock stopping point, so I want to respect that. Let's move on to the next slide. We will provide you with contact information in just a moment for our presenters, and feel free to contact them if you have additional questions. I want to make you aware of our upcoming January session for the Better Buildings webinar series. Correction there, this will be 2014. It is in the new year, January 7th, 3 o'clock to 4 o'clock, and this will be focused on kickstarting your energy management program. We have Jackson Love from Shorenstein and both Better Buildings Challenge partners, Kelly Bolton also from Allegheny College, and both of these folks will be talking about how they have really started with a little bit and used some interesting and innovative resources to build up their energy management programs. I encourage you to register for that. You can jump right on our website and register today for that session. And let's move to the next slide. Here's contact information for all of our presenters, as well as myself and the Better Buildings Alliance lead, Kristen Tidonio. If you're interested in more information about the Better Buildings Challenge or the Better Buildings Alliance, please don't hesitate to contact us. And encourage you to follow us on Twitter for all the latest information about the Better Buildings Initiative. So thanks very much for joining us today. We'll hope to see you in 2014. Thanks very much.
Hello.